Good day, everyone, and welcome to my channel where we make structural engineering design simple and easy. My name is Olodukonyede, and I'm your host. I want to say a very big thank you to everyone who has subscribed to this channel. I want to say thank you very much. And those who are yet to subscribe, please go hit that subscribe button, hit that like button, share the video. That is the only way you can show us that you really appreciate these videos that we've been putting out. We've been putting out. Thanks to everyone who has sent in their comments, encouraging words, and asking questions. We want to say thank you very, very much. Today we got a question from one of our subscribers. His name is Idris Issa Osheza. Osheza. Issa, you didn't tell us where you are commenting from, but please, on the comment section, you can tell us where you are commenting from. Where you are commenting from. You said, "Good day, my engineer. Please, I need a video on how to call out my reinforcement in slabs." You want to know how to call out your reinforcement in slab, and that is what we are going to do today. That is what we are going to do today. uh Looking at this is how your typical um, reinforcements, calling out your reinforcement should look like. This is the typical way you do that. This first number is the number of the bars, the number, how many bars you are putting there, how many bars you are putting there. The next will be the diameter of the bar. After the diameter of the bar, the next thing you need is the bar mark number. Bar mark number. Then the next is the spacing of the bar. And finally, the position of that bar. Position of that bar. We explain further. We will explain further by doing a typical example. So, but with this is how you do your calling out of the reinforcement. The number of your reinforcement, how many reinforcement. Like with this now, we have our diameter 12 12 reinforcement. The number of time we used it was 62, and the bar mark is 61 at a spacing of 150, and it's at the bottom bar. It's at the bottom bar. And also, how do you determine this bar mark? How do you determine which reinforcement takes this bar mark? What you do is how to determine your bar mark. The first thing you do for you to call out your bar mark is, if the reinforcement, they all have the same diameter, if the reinforcement have the same shape and they have the same length, you group all as one bar mark. So if a diameter is y12 and it's a straight, let's assume it's a straight bar, and its length is 12 meter. So every bar you use that has the same diameter, the same shape, and the same length, you call them, let's assume what we are doing, we'll call it 1. But if the shape is different, we'll call it the next one. So it all depends. Even if two of them, the bar diameter is the same, the bar length is the same, but the shape is different, you name it another bar. If the bar diameter is the same, the bar shape is the same, but the length is different, you name it another bar mark. If the bar diameter is different, the bar shape is the same, the bar length is the same. You name it another um, number. So all three must be the same. All three must be the same for you to call that bar mark 1 or 2 or 3. So, but if any of them changes, you change the bar to another. So with this, let's look at a typical example. So as we are looking at this, if you see this is a shape, please check our previous video how to determine this length, return length. I think we've explained something of such. So, but if we have to re-explain that, I think we do that. So if we have to re-explain that, we say 1.25 multiplied by 0.25 0.13 times the length So that is how this return. If this is 4.5 meter, the return of this that we've already said would be 1.25 multiplied by 0.13 multiplied by 4500. So our return length will make it 800. So you are returning this 800. That is how this return bar of the return length came about. So this is it. Check our previous video, we explained it more even at this support area. So but what we are talking about is how to determine this. So if you look carefully from here to here, that is where, like this, our bar, we are going to space it from this edge to this edge at a spacing of, we are spacing this at 150. So but how you determine that is from your design. This when you are detailing, you're already done with your design, so it is what the design tells you to do. That's the spacing you use. So for this designer, we are using 150 of this 150. So you do, most time how I do it, two ways. The way I do it at first, I could take this length, we'll do it this way. Let's do it this way. We'll say, if we take the length, which is 450, we use any 450, now divide by the spacing. Plus, we do plus 1. Plus 1 will give you our answer. Okay, we can say, instead of that, let's say length divided by spacing plus 1 will give you the number of the bars. So I think this explanation should be easy enough. So we do length divided by spacing plus 1 equals to the number So if we come here, now, two ways. The bar, this length, they took the length from the middle of this beam to the middle of this beam, but our bar is not starting from the middle of the beam, so we have to take out this. We are starting from here. The easiest way you either subtract that from it, or you just take either which one, the one that is easier for you to do, please do that. So with this, we can now say we can do spacing of even 25. I just move 25. Okay, 25. So what we are doing here is we are giving the bar the concrete cover, so that there will be space, and the concrete cover, it must start after the concrete cover. We'll put our first one here, and we'll put the last one here. So in between here, this becomes our length 4220, and our formula says length divided by spacing, which is equals to 28 plus 28 approximately. We say add 1 to it. If you add 1 to it, it gives you 29, and this is how this 29 came about. So if I want to, because they added others, now they added others, same thing, same principle. Every of this that you've done, like we said, this they are all same bar. We are calling them same bar. So you add up every of them that are the same bar. We add them up. And you get this number of your bar. Then y12 is the diameter. Of our bar, and 01, which is our 01, which is our bar mark, is this, because they are all the same. They are all of the same shape, same diameter, and same length. Even this is of the same shape and the same length, but the difference they have, we could have just used one for all, but because this was space 200, so that you can identify that yes, same bar, same this, but on getting here you reduce your space. So this is how the number came in. And the next one is the spacing. That is why we knew that this is spaced at 150, while this will be spaced at 200. Then the position it is the bottom. You place it at the bottom. Why? If there's a top, you see T. You make it T, showing you that reinforcement should be at the top. If you see this, all these are showing us that they are at the top. So this is the bottom reinforcement, while this is the top reinforcement. So with this, now we know that this bar, if you want to read it, is 37 in number. The diameter is 12. The bar mark is 1. Spacing is 200, and the position is at the top. So with this, you can easily do all your design, and on this part, how this was arrived, I think I've already explained it. When you are at the where the bar, this bar is returning, is not continuous, you use 0.13. But in a place where it's at it's a continuous bar, instead of 13 we use 25 0.25 0.25. So with this you can now determine, okay, we say the length here is 450 4.5. We do 1.25 multiply by 0.25 multiply by 450, and we have 1.4 approximately. You can either do 1.4. Let's see what happened if they did not use 1.25. Okay, plus or minus. Good. So this is how you get this. So same principle if you are at this continuous bar. But when you are at this part that is not continuous, all these parts that are not continuous, please use 0.13. But if it's on the continuous part, you use 0.25 times the length. On this part, you do 0.25, 1.25 times 0.25 times the length. The length becomes here. At this part, the length becomes here. At this part, the length becomes here. Even at this part, when you're dealing on this direction, the length becomes here. So it all depends on what you are doing. So Isa, I think this explanation it's explained as much as I think anyone would need to understand. But if you still have any other question, please still send it down on the comment section. And when you are commenting, please tell us where you are commenting from. So if you still have any question on how to call out your bars, your bar, please let us know. And if you've been benefiting from this program or videos and you are yet to subscribe, please go hit that subscribe button so that when next we put up our videos, you'll be the first to know. So until I come your way next time, please keep sending these messages. Please keep subscribing to this channel. And if you still have any question, please send it down. We will definitely answer those questions. Thank you and God bless.